Alright.
Okay, so we're doing
Just see if this thing's low again.
No.
Today we'll be doing titration. Titration is a procedure for quantitative analysis that analyzes the concentration of the analyte solution. Ours is going to be 100th molarity of NaOH, the stoichiometry of a reaction, the number of electrons gained or accepted in a redox reaction, and also the solubility of products. Our standard solution is going to be potassium hydrogen pithylate, or KHP. Here we're adding the indicator to the KHP, and that's the initial point of the NaOH. Our indicator is phenolphthalein, and what that does, that will change color when there is a change in the chemical or physical property of the standard solution. And with titration, you're going to slowly add the analyte solution to the standard solution until the endpoint is reached, which that is where the change has officially occurred, and the color will change for us to a very pale pink. If you get very pink, then you have done it wrong. And once you feel that you've met the endpoint, it's easy to compare it with a clear solution, and also having a white sheet under helps to see the color better. For titrations, you are measuring the point at which the concentrations are equal, and you can also figure this out stoichiometrically, and that will give you the equivalence point. However, the equivalence point usually is not the end point because of error or such. And here you can't tell, but that is the pale pink. And what you're doing to find the amount used is you're doing the final volume minus the initial, and that gives us 33.4, which is the amount used. Again, when you're doing titration, you want to make sure that the tip of the burette is in the flask holding the standard solution, and that will make sure that you minimize splash in order to give you a better quantitative analysis, because you don't want to have much error. And before you begin the procedure, you want to prep the burette, and you again want to do this by putting three times cleaning it out with deionized water, and 3 times cleaning it out with the solution used, and ours is NaOH. And the same thing for cleaning it, except this time you use 3 times deionized water, or 3 times tap water cleaning it out, and 3 times deionized water. And here our endpoint has been reached. You want to make sure that it's close. We're going to show you what happens when you overshoot it. If you put too much solution in it, then what will happen is the solution will actually turn pink, and that's not correct. And again, you want to do the initial subtracted from the final volume. And again, we're adding phenolphthalein. You want to add 3 to 5 drops. You don't want too much. Whenever the burette is going to be numbered in a descending manner, it has 0 at the top, and then it goes down to 50. So, and you want to continually be stirring the solution so that the pink is able to, or the analyte is able to reach all of that, and that will give the pink color. It will absorb back into it. The indicator can actually, depending on which indicator is used, you want to use one that doesn't change the reaction, and the minimalist amount can use, but something that also you can tell what's going on. What you want to, it can detect the pH conductivity or the absorbance, and that's something that it can change to depending. Again, once you feel like you're close to the endpoint, you want to slowly add it until you feel that it's reached. A lot of times asking other people or comparing it to different solutions will help you, and that's going to be the endpoint that we had. And just like with the other ones, you want to subtract the initial minus the final, subtracted from the final